All right. So who am I? I'm the director of Synergy, my company, the company organizing this event and a few others. I'm also a consultant, Microsoft MVP, and organizer of a few conferences and sometimes use groups that you may have heard of. PSConfEU, obviously, PSD UK. We're not running PSD UK in 2024, maybe next year, but we are running a PSD CH in Switzerland, in Lausanne, the 27th of February, 2024. So if you want more information about that, please reach out to us. So today, the session is collaborate through Git, how to get started with it. So the Git is something that you can't work without Git nowadays. If you're doing anything, sysadmin related, configuration related, we even talk about YAML engineering, where you have to change YAMLs. You still have to go and use Git to be able to collaborate with those files. And if we use the very loose terms of code, all the code should be put into Git. But it's not as straightforward. And sometimes I would say the explanations are not really convincing. And maybe there's different levels that you can have with Git, but when you get started, it's very confusing and not very helpful, because sometimes the documentation you land on is aimed at developers who've been doing this for decades. So let's just say you're a scripter, or you're someone that writes some codes, even if it's some YAML or some PowerShell or something else. You're a coder, and you've grown out of mailing your script. You're not sending an email with, hey, this is script version 1.2.3. Or this is my new script. You can access my new script on this, in this file share. But it's odd, how can you share your script in a nice way? And maybe you're not yet at the point where you're using the PowerShell gallery or your own internal gallery to share your scripts. And it worked on your machine. And that was great. But then, we've put it into Git and then something happened to it, which we're not sure what. And what do we do now? Because it doesn't seem to be working anymore. My version, or the version of the file system, used to work. And how do we put it from the, Git onto that server that we have over there? And then, Bob screwed it when he merged his changes with mine's changes. And obviously it's Bob's fault, right? Or not. How can we use my branch, because I'm doing everything through Git and he's doing everything through Git, but I trust my branch and not his branch, or not the main one. So I would prefer to use my branch than the main branch. All of these kind of issues usually emerge when a team is not really aligned in the way they work with Git. So today we'll try to have a look at, how to get started with Git, but not as a tool, just to understand the principle around Git and, what is it trying to do and how we can use it and leverage it to our usage. And as a team, how can we collaborate through Git? So the first thing I would like to say, and that might go against, in a way, what you've read, is Git is just not about version control. It's a collaboration tool. The first thing is it tries to help you collaborate. It's distributed. That means you have one copy on your machine and someone else has another copy. And there's another copy on a server. But this is just not about the version. It's about how do these copy collaborate together in a distributed fashion. And if you look a little bit events, celebrate on things where changes happen all the time in those different repositories. And if you think about it, in a way, you are managing timelines, because everything that happens in one part as one event, then another event, and another one, on another one. So you have a sequence of events. But it's also managing multiverse, because you have your continuity of events, and someone else has another continuity of events. So how do you have one timeline on one repository? And how do you manage that against someone else's timeline on their repository? So this is multiverse and timelines trying to work together. So the good thing is with the recent, recent or not so recent movies, you've learned how to do this. You've learned the best practices. So now we just have to review them and then go back and then just try to apply those same principles in a simple way when you're trying to collaborate with Git. So can you remember when was your first, or maybe one of the first? I can remember my first introduction to Git principles. I realized it was one just many years later. That was the first part where I said, oh, actually, I learned about Git branching and Git principles many years ago in that movie, Back from the Future. So if you look at this, especially that, what is growing is you have a timeline of events, and you have a branch, which is what you're doing with Git. You're branching out from a timeline. So if something happens into a different timeline, will they exist in the other timeline? And how do you cope with those changes if they are not in the same timelines? You have to go back to the future to be able to change the things, right? So that's the kind of thing which actually help you visualize what happens in a Git system across the different users. And this is how we will try to simplify what happens to be able to collaborate. So it's a change of event on the timeline. So you have a timeline, you have a start at some point, and then you have different events. And these are your commits. So your first commit, and then you have your second commit. And then you make another change. There's another commit that appears to it, and so on and so on. Different commits happen on your main timeline. But the history is relative. What does that mean? This is the main timeline, which, if you think in Git terms, this usually is what is stored in your remote. So, when you have the remote origin, this could be your Bitbucket server, your GitHub server, or, whatever GitLab maybe server you have. This is what you see over there. But you create a copy on your local machine. But that's still a copy of what's happening and what is viewed by everyone when they access your main server Git repository. So then you will say, well, I want to do some changes. I have the copy on my machine, and I will branch out for my own changes. So it's Gael's relativity. It's my own changes. And I will start from there, from the last event I know of, from main. And everything after that will only exist in my branch, my relativity. So I make some changes, and I add some files, I commit, so that means that creates new events, change events, and then I will add more things to it. Finally, something happens, on the other side, on the main branch. Someone else has been doing some work, and they've pushed their changes to that branch. We have different history now. I have my changes I've just made. The main one has other changes someone else has made. The problem now is, how can we have something in common where we have all the changes together? Basically, we have different history. Main has 4 commits, and the last 2 are not. They don't exist on my relativity, on my reality, on my branch. But I have 2 commits that don't exist over there. So one way of doing it is to merge things together, but that means the new branch, what you see on the screen in green, doesn't really have the same history, the same past, because they have the 2 merged together, but they're not aligned. So it's a bit of both worlds. It's like when you have two universes that just collide together, when you have a character from one universe to a character with a character of another universe, and they just, bump into each other and they create a new world together. So that creates a merge commit, and I say it's bad. It's not bad in every situation, but if you don't know what's happening, it's bad, because it means that you have different history, and it's very hard to understand what's happening and where things are coming from. And when you start with Git and you start collaborating with your team with Git, usually in your repository system, so Bitbucket, GitLab, GitHub, you will see when it's a merge commit. It will flag it with an M or something, and it will be kind of like it's coming from a different branch, a different source, if you want. Try to avoid this. It will really make your collaboration much easier, and we will see how. There's another issue sometimes where you try to use branches as a way to make some releases. So here we have a QA branch and a prod branch. And in theory, everything goes through QA before it goes to prod. So we've got the first event, which is the same in QA and prod, and the second event, which is the same again. And then we've pushed, in QA, we've pushed the changes as well, and this all synchronized, and every time we have the same events replicated from QA to prod, which is great. So now imagine we keep working, and then we have some more commits coming on into QA. But you see on QA, you've added 2 commits, but now you have something very urgent that needs to be fixed in prod. If you fix them in prod, you will add another commit here directly, which won't have any commit in QA. So you will have something here that exists, something in QA that exists, but it will not have the same timeline because the event's not going to be the same anymore. So if you do that, either you have to add a commit to QA, maybe you haven't finished testing these 2 new commits, and you will have to push the 3 commits up to prod. Or, because those haven't been completely tested yet in QA, you will have to create new commits there that will make it to prod without going to QA. And in that case, because it's a quick fix, maybe, those 2 commits the commits on QA will get out of sync with the commits into prod. It's not necessarily a problem if you know what you're doing, but usually it really makes it much more complicated when you try to collaborate with your team across 2 branches like this. So try to avoid a branch that its only job is to stage before going to the next branch. I would say you should prefer building artifacts from a main branch, and then those artifacts is what you will be releasing to production. Try not to use, and in many cases, try not to use branches as a release mechanism. It's just going to make it a bit more complicated, because then you will have to manage the different timelines from prod and QA. And what I'm telling you here, it's an opinion. I'm not saying it's always the case. I'm saying, in my opinion, it's easier to have a QA. It's easier to have one main branch than a QA that then releases to prod. Because it's easier to have one single timeline of events that you manage across your teams. You create artifacts from them. So whenever you're happy with one bunch of changes that you've made, so a lot of commits, you will say, well, I'm going to create an artifact from here. I'm going to test that artifact, and I will tag the commit this artifact relates to. So I have one artifact that I can deploy. Maybe it's a PowerShell module. Maybe it's something else. And then I can use this artifact created to deploy it to a server, a PowerShell module version 1.2.3 that matches commit 1, 2, 3, 4, 5, 6, 7, 8. And this artifact can be deployed to the servers, not using branches. So how we change and how we converge those relativities. So back to the example where we have the main branch, which is out of sync with the Gael's relativity, because I created a new branch and new commits have been added since to the main branch. So one way is to do a git pull. And the git pull will, by default, take the commits from the main branch and add them to my relativity. The problem now is between main and my relativity, we have a difference of events. So each commit being an event, I have two more commits which are before the two commits from main. So we are out of sync. We have different timelines, different events on these branches. And if you don't rebase, if you pull without rebasing, that's what's going to happen. The good way to avoid this at all costs every single time is to configure Git to always rebase. So that command git config -- global pull.rebase true, that will always tell your Git, if I say git pull, make sure you rebase, and we will see what a rebase is in a second. I'm afraid I forgot to mention, I'm afraid I can't see the chat. So if you have questions or things like that, we will leave them to a bit later. I have plenty of time for questions. But at that time, just please come into the Q&A area, and then I will take some questions. I will make a stop just after the rebase. So how does the pull rebase work? So if you, instead of doing git pull, you do a git pull -- rebase, or you do a git pull and you have configured the always rebase configuration settings, you have the same situation there where you have two commits on main that you don't have on your local branch, and you're trying to rebase from there. So you would do git pull -- rebase origin main in that case. So it's going to set aside those two commits that you have there, but that don't exist on main. And then from here, you have the same history as main from where you branched out. And then you will pull what you're missing. So you pull the two commits you're missing, and then it will automatically re-add those two commits after. What may happen at that point is if you change in those two commits that you just made on your local branch, if you changed the same files as you had before, it will try to resolve the conflicts. And that's why it's better to do that often enough so you don't have a huge change set every time you're doing this. So let's just make a pause here. So when you do a rebase, it's just set aside, the same thing as git stash, set aside, your current work. So in this case, it's the commits, not really like git stash, but it set aside your commits. It will pull the commits that are missing from wherever you tell them. So origin main in this case. It will pull them down and then re-add after that the events. So you have the same history plus the two commits that you just made, the two change events that you made on your branch. So now if you would want to do a pull request, it will be the same history as you have in main, and it will only be the difference that are brought by those two commits there. So enter the Builtiverse. And yeah, thank you, Marvel, for explaining it. So the change event timeline, as we saw, there's one main event. And let's say this is, this is on the GitHub side. And then we have the local copy, which has a copy of this timeline. We just did a git clone of our repository. Then we create the branch to create our own working environment, which is just a branch from main at this point in time after this commit, which is the same as the one on GitHub. So from there, we just want to add more changes because we've changed some YAML files as an example. And then we add that, we create the commits. We've tested locally, it seems to be working, we're happy. Then we push the branch up into the remote, which is on GitHub, which is where we copied the main branch from when we did the git clone. So we say, hey, git push, set me you need to track the local branch, which is called Gael's relativity, to the remote branch, Gael's relativity, and then you push that to the origin remote. So git push -u, that's the short version, origin, Gael's relativity. After this, we have the same copy, but maybe someone made a change and merged it to main before we could create the pull request for Gael's relativity. So what happens there is we are out of sync. So how do we fix that when we work collaboratively? So, sorry. Oops. So from there, we do the git pull, sorry. So instead of just the git pull, we do git pull rebase origin main, which is coming from the main from the GitHub server, which has the 2 commits. And then we will set aside the 2 local commits that we have on our branch. So we set them aside. And we will pull the one we're missing from the origin, so on the remote server, main branch. So now we have the same history as we have on main in the GitHub, in the origin. And then we can add the last 2 commits. So the commits change colors in the screen because it's not exactly the same commit as we had before. So if you compare your branch that you have locally, which is called Gael's relativity, and the branch that you have on GitHub, which is also called Gael's relativity, they are not the same anymore because they have a different history. So the commits that we created are not the same either, so they have a different git commit ID. If you try to do a git push from here, you will have an error saying you're not allowed to push this because there's something wrong with your history. Something is not right. If you push false, then you can replace what is on your branch because it's still tracking it, because you know that your local copy is correct. I'll do like a quick note, and I will get back to the note. There's another thing that's just a false, but if you try to apply that to so in this one, it's called Gael's relativity. So I assume I'm the only one working on this branch, and no one else is working on that branch. So I know that my local copy, the one that we based, is the correct version. If you start collaborating on one branch that you have, there's something else that you need to do that I will cover in a second. So we replace it, and because the history is the same, you can see that it has all the commits that we had on main, and only on the branch, you can now see the 2 commits that were missing. So if you do a pull request from this branch to the main branch, you will only see the changes from these 2 commits. And this is a position that you want to be, because you don't want to have a pull request that has your changes plus the other changes because they were out of sync. The history was different. So you create the pull requests, and now you're fine. You can see that in doing so, I've never pulled these 2 commits that were on the remote, on the GitHub server, I never pulled them onto my main branch. So if, in the meantime, you want to go back to your main branch, remember to do a pull to be able to get those. And in theory, probably in this way of working, you should try to avoid making any change on your main branch and make sure you keep it up to date as much as you can. So the note is, when I say you do a git push and false, and so when I did this presentation during PSConfEU as a quick presentation that was not planned, Jakob said, well, you should not use -false. You should use false with lease, which is correct, especially, and this is especially important if someone else is helping you with your branch and maybe did a pull request with your branch or change something on your branch, the branch you were working on. False is destructive. So you would erase whatever changes they pushed that you didn't have. If you do false with lease, it would try to force the changes, but if something is missing that you didn't have in your local branch, it would not replace it. So it's better to use false with lease, But if you know there's only you working on this remote branch, and only the current copy that you were using, false might be okay. So let me just go out of the screen, and then I will stop sharing, and then see if there are questions. Is there any question with this? Someone can come in the Q&A area if they have questions. I would be happy to help. Okay, no one. If it helps to visualize it, press F on your keyboard. Okay. Thank you. And if you're still confused with Git, press X on your not X, sorry, press Z on your keyboard. Still confused? Press Z. Okay, no one's confused. I guess when you press Z, it does this. There you go. Some people do. Yes. All right. Maybe. Okay. I'll take. Yes, it's the little dance. Rezzy loves it. so the little dance that is telling me that yes, it's confusing. So I'll go back to the beginning of the slide, and then I'll try to just explain, why there's different ways of doing it. Okay, so let me share again my screen, if I can. There you go. Let's go back with PowerPoint. Yes, no? Okay, computer says no. There we go. So let's go back to the beginning, if I can. Let's go all the way up. Okay. Let me check. You can see my screen again. And no, it's not shared. Let me just try again. Window. This one. Share. Thank you, Gael. There we are. So, so obviously you've got that point. Let's go just straight to the timelines. You remember what when I showed you, what happens with the events? You have the past, you have, the year 1985, and then you have another 1985 that changed a little bit. That's when we branched out. So we have a different reality. Whatever happened into one timeline didn't necessarily happen to another timeline. So we need to sync those timelines if we want to merge the work together in one way or another. There's different kind of merge. There's the one where you take the bits from one side, one timeline on the other timeline. So you just take the changes, what's left in the files. But that means you lose a little bit of the history of events. So you don't get the date, you don't get the commit IDs, like it would be slightly different. You would get a bit of both. It's a bit of a mix. Or you try to say, well, these happened first, then I will take my changes and make them happen after. So I will just make sure we realign the history and realign the timeline. So let's go back to something simple. We have a change of events that happens, and the history is relative to your branch. Commits that happen in one branch don't automatically populate to the other branch. We add changes to a branch by manually creating, adding files and committing them. And we add, some information about what we're changing with the message. And then someone else might be, or maybe us, if we want to, in parallel do some other work that needs to go to main quicker than what we're working on. Then it goes to main. And then we have two branches out of sync. One is the main branch, and the other one is your local branch that you're making changes to. If you try to merge things together without rebasing, you will have something which is a mix of the two but not exactly those two. It's not exactly one or exactly the other one. It's really a mix of these two. I mean, the dates and the things are a bit mixed together. Hopefully, that could work in some cases. I'm just saying that if you have many people collaborating and quite new to Git, this will be tricky to understand, because it will be tricky to understand what things are coming from. So if you can, always rebase. Otherwise, if you're not rebasing, it's called merge commits. And you have configurations in the branching strategies of your remote that you can configure. And usually you want to allow forward only, so always adding up new events. So fast forward only, sorry. Or the other, and sometimes you want to rebase and fast forward only. You want to avoid merge commits. Again, be careful when you have prod and QA, because if you use QA as a staging branch for prod, if you have changes that comes to QA, but you want to do an extra change that goes to prod directly, then either you lose the synchronicity between QA and prod, you need to push every new thing. So the 3 commits, if you add your extra change it there, you have to push all of it at the same time here to keep prod and QA in sync in terms of timelines. And when you want to pull the changes that comes from a branch to your branch, you pull them. But the default of pull, when you have not configured your Git, and maybe you configure it locally in your repository, or the best, as I recommend, is to do it on the global configuration in your systems. By default, it would do just add the things after your changes, the default Git pull. But that's when you don't rebase. So configure your pull rebase to true. And then the next time it will rebase, it will set aside the commits that you've made. It will, again, pull the changes and re-add at the end your events. So then you're only left with the changes, the addition that you've made to it. And remember that you have your local copy and the remotes, and everyone has a local copy. Everyone collaborating on that project has a local copy, and everyone is sharing against the remote. So you have GitHub as your remote in this example. You have your main branch. You clone your main branch locally to make your changes. You create a branch for you to work on. And this is your new reality. And you're making change to that. But if you've made the changes, and at the same time, you push them, obviously, to save, to have a copy, because maybe you don't trust your hard drive. You want to push them. So you push them to your remote, to GitHub. Your branch exists now into that remote, but someone else may have, created a pull request and changed main. By the way, I didn't mention it, but sometimes, or most of the time, you want to protect the main branch for people not to push directly to main. You want people to push through a pull request. One of the reasons, there's several reasons for that, but one of the reasons would be to have tests to ensure the quality. But I would say the key reason I like to have always change main with a pull request with at least one person to approve it is because then you share the knowledge, say, hey, I'm making some changes. Make sure that makes sense, because I don't want to be the only one knowing about this change. That's the main reason I would say for always changing main through a pull request and never directly with a Git push. So now that those people are aware of these changes, and then in this case, there's a change in main that you don't have in your local branch, you will do your pull rebase, which is again locally. So you git pull rebase origin main. You will set aside the new commits that you have made, automatically pull, the commits you were missing, and then re-adding those into your branch, the one you created. It's re-adding the same changes, but it's not going to be exactly the same commit ID. So next time when you push, it will fail because you're not allowed to change the history of your branch. So you have to force it, or as we've seen earlier force with lease in case someone else added new things to relativity and you wanted to tell you about it. So you git push force, and then this will add only your two commits after the last commit in main because you've made your rebase. And now you can do your pull request, which only will have the diff from the two changes, the two commits you've made here against your main branch.